Okay, in this video we're talking about atoms and the periodic table. So some basic information that you guys need to get down about atoms. We got a model here, but you need to know what the names of all the subatomic particles are that make up an atom. And so I say subatomic whenever you guys hear me say that. If I haven't already told you, if you think about that word, sub meaning below, and then atomic, so below an atom, smaller than an atom. So that's why these are called subatomic particles, is they're smaller than the actual atom. They actually make up the atom. So you got to know the names of them: electrons, protons, and neutrons. You also need to know what charge they are. So electrons have a negative charge, protons have a positive charge, and neutrons have no charge at all. And so the way I kind of remember this, neutron kind of sounds like neutral. And if it's a neutral subatomic particle, it has no charge to it. It doesn't affect the charge at all. Protons are positively charged. They start with a P. P for positive. Should be pretty easy to remember that. Electrons, I always think of electricity, and it would be a negative thing to get electrocuted by electricity. So electrons are negative, protons positive, neutrons no charge at all. So if I ask you a question in class or on a test, what is the overall charge of an element, then you have to look at how many protons it has and versus how many electrons it have. If it's 1 and 1, then it has no charge because the positive and the negative canceled each other out, and it simply is a neutral atom. If it has more protons than electrons, it's gonna, say it has 2 more protons than electrons, then it would have a +2 charge. Same thing goes for electrons. If it has 2 more electrons than protons, it would have like a or a -2 charge. As far as mass goes, what makes up the mass of an atom are protons and neutrons. They have 1 AMU, 1 atomic mass unit each. It says no mass for electrons. Obviously, if it had no mass, it wouldn't exist, so that's not completely accurate. I'll show you another thing here in a second that kind of shows you the actual mass. And then you need to know where each of these are located. So within the nucleus, we have protons and neutrons. So right here in the middle, that's the nucleus. That's where they're located. Remember, if you're thinking about the mass again, all the mass is in the nucleus with the protons and neutrons. Electrons are located outside of the nucleus, so they're orbiting around the nucleus, and they take up all the space, but this is mostly empty space here. You just have a bunch of electrons in there. Also know for the test, know the current model that we go by for an atom, the current atomic model, which would be the electron cloud model, and that just gives us, tells us a bunch of areas basically where you're most likely to find an electron moving. So electrons are constantly in motion. You can't tell at any 1 second where it is, but the electron cloud model kind of gives us a region where you're most likely to find an electron. And we'll talk more about that in class. Okay, so the mass I showed you, it doesn't have no mass, but so protons have 1, neutrons have 1. Electrons have 1 divided by 1,840, so it makes it significantly smaller. It's just saying that it's negligible. You don't have to take that into consideration when we're talking about mass. Okay, looking at the periodic table, there's a lot of information, a lot of patterns that you can see in the periodic table. So just starting out, we need to be able to get some basic information from the table for physical science here. So if we look at each one of these squares, they're going to give us some information. This is just kind of the example. It uses mercury as our example. So it's going to give you most likely the element's name, the atomic number, we're going to talk about what that is, the symbol, and then average mass. Those are the things that you're going to have to be able to get from it. You can see in this periodic table, which depending on what periodic table you're looking at, they have many different types, many different versions of the periodic table. This one actually gives you the atomic radius. You guys do not need to know that for physical science. So let's look at these. So if we look at the square, atomic number, it's usually going to be a solid, or not a solid, but a whole number. Atomic mass is usually going to be down below. Sometimes they switch these depending on what version of the periodic table you look at. But just know atomic mass always has the decimal point. Atomic number is a whole number. Okay, so looking at these, what information does atomic number give us? You can see I have it twice here because atomic number gives us the number of protons for an element. It also gives us the number of electrons. So that atomic number, if we go back, 6 for carbon gives us, so we have 6 protons and 6 electrons in that element. Mass number. So the mass number is the number of protons plus or atomic mass. Sometimes, though, there is a difference between those. Sometimes they're kind of used interchangeably. So atomic mass and mass number. But basically that gives us the number of protons plus neutrons. I told you guys earlier what makes up the mass of an atom. That would be protons and neutrons. So if we're looking at the mass number, it tells us number of protons and neutrons. So let me go back here. So here, if we were wanting to find number of neutrons, so we already know this is our protons, number of protons and number of electrons, right? So how do we know the number of neutrons? Well, if this is protons plus neutrons, because those make up our mass, then all we have to do is subtract this number, which gives us our protons. So subtract our protons, which is 6, right? Our total number is 12, roughly. We're just going to round it. And so what's left over? 6. So that's how we find our number of neutrons. And you guys have to be able to do that. Okay, let's move on here. Just a difference between mass number and atomic mass. Mass number is always a whole number. That gives you the number of protons plus number of neutrons. And then atomic mass is an average weighted or a weighted average mass of all the various isotopes. So we're going to go over isotopes more, but basically what an isotope is just another version of the same element. Usually it's going to differ in the number of neutrons, so it's going to have a different mass. So you could have like something like carbon 12 and carbon 13. They're both still carbon, they just are different versions or different isotopes, basically. And so if you find a weighted average mass, it's going to give you a decimal in there because it's an average of those. So if we look at these, this is just kind of an example. This is a list of some of the elements and their isotopes. So if we look at oxygen, we have oxygen 16, oxygen 17, oxygen 18. Gives you a percentage of how often we actually find those in nature. So naturally find those. 99% of those atoms of oxygen are oxygen 16, and then a small percentage are different. So that's what you're going to find on the periodic table is an average of all the isotopes. Now to find that, you guys do need to know how to find an average, a weighted average mass. So to do that, you have to take the mass of the atom. You're going to take the mass of one isotope, and then you're going to multiply that times the percentage that it's found in nature, plus the mass of the next isotope, times the percentage that's found in nature, and you can just keep going depending on how many isotopes they have. You can just keep adding that same grouping there, percentage, and then you can just keep adding. And then you divide it by 100, and you're going to get your answer. So an example of that would be, in this case, oxygen. We've taken oxygen 16, that's one isotope, times the percentage that's found, plus oxygen 17 times the percentage that's found, plus oxygen 18 times the percentage that it's found, divided by 100, gives us about 16 AMU. So, and then we won't go over that one. So you guys are going to have to be able to find that in class. So real important, you need to write down this equation here. So mass times percentage. So write down average atomic mass equals mass times percentage plus mass times percentage divided by 100. Okay. Going the wrong way here. Okay, another thing, you guys need to be able to do Bohr models here. So if we look at a Bohr model, we've talked about this in class already. In the nucleus, usually with a Bohr model, we'll do one here in a second, but let's go over the energy levels actually first. So the first energy level, so they start from closest to the nucleus and then working your way out. So this is the first energy level, and this would be the second energy level, third energy level, and the fourth energy level. In the first energy level, there's a max number of electrons that can fit in it. So it's a small energy level, so it can only fit 2 electrons in it. As we move out, they get bigger and bigger. We can fit more electrons in there. So the second energy level, the max number is 8 electrons. And you guys need to write this down somewhere so you kind of get these numbers memorized: 2, 8, 18, 32. And so the third energy level is 18. Fourth energy level, you can fit 32. So let's kind of look at an example of that here. So in the nucleus, whenever you guys do a Bohr model, you need to write basically, you can write the symbol. So let's do an example. Let's do lithium. So lithium, this is just kind of a small element here. Lithium, if we look at the periodic table and look at the atomic number, we have 3 protons. If we look at the atomic mass, and then that would be 7. So we'll subtract 3 from 7, and we have the number of neutrons. It gives us 4 neutrons. Now the number of electrons is equal to 3 also, because that's our atomic number. So if we were to fill in our Bohr model here, the first energy level, we can only fit 2. Then we have to move out to the next energy level. So our third one would be in this energy level right here. Now if we had a bigger element, say it had 12, and you guys can actually look that up, which one was 12, that would be magnesium. So if we had 12, then we've put 2 in the first energy level, then we'd fill this up till we got 8. So we have 4, 5, 6, 7, 8. So now we have 10 total. We need 2 more, and then we start filling in on the third energy level. So we can fit 18 on that one. So then we'd be done. So that would be magnesium. So again, 2, 8, 18, 32. Those are the magic numbers you need to remember. Okay, so we'll be working on some of this stuff in class. Take notes over the video. And then I'll see you guys in class.